Now we need to look closer at the mediastinum and specifically the heart and the pericardium that are housed within the middle mediastinum. So when we look at the middle mediastinum, the pericardium is going to be really important. So we're going to focus on that, looking at all the different layers and where the cavity sits in relation to those layers. But we also need to look at how it fits into what we've already discussed. So if you'll recall, the lung is covered by parietal pleura. Specifically, it's the mediastinal parietal pleura that's going to be intimate with the mediastinum and the pericardial sac covering the heart here. And so you can see that that is going to be a very tight area, but that is where the blood supply is going to be running. And so if we look at the thoracic wall, that's where we're going to see the internal thoracic artery traveling here, just when it comes off the subclavian. And so it doesn't travel very far inferiorly before it gives off the pericardiacophrenic artery, and the accompanying vein will travel here in the space between the pleural sac and the pericardial sac, their outer layers. And it's going to innervate and supply everything that it touches all the way down from the pleural sac to the outer covering of the pericardium to the pleura covering the diaphragm and even the diaphragm itself. So let's look closer at what that means.
Here in this lateral view of the thorax, you'll see the mediastinum itself actually has the same superior, inferior, anterior, and posterior boundaries as the thoracic cavity. We simply subdivide it into the pleural cavity and the mediastinum by using the mediastinal parietal pleura. So housed between the parietal pleura is where we find our heart and great vessels and a number of other structures. For descriptive purposes, we use the transverse thoracic plane. We discussed that this was at the sternal angle, and this is an imaginary plane that passes all the way back to the fourth or fifth thoracic vertebra and pretty much through the arch of the aorta. It's essentially at the beginning of the arch of the aorta all the way to the end. So it's right where the ascending aorta ends, as well as where the arch of the aorta begins, and then all the way to where the arch of the aorta will end to begin the descending thoracic aorta. So this transverse thoracic plane, we'll subdivide it into the superior mediastinum above and the inferior mediastinum below. So we further divide the inferior mediastinum into anterior, posterior, and middle using the pericardium itself. So housed completely within the pericardium is the middle mediastinum, and that's what we're going to be interested with today. Anterior to this, in the anterior mediastinum, since you are going to encounter endossection, you may find some fatty tissue. Majority of that will be the fatty tissue related to the heart, unfortunately, but some of it may be from the thymus. The thymus is technically almost gone in a number of adults, but in some individuals, the tissue involutes and remains as kind of a fatty tissue, but it would be outside and not attached to the pericardium. So here you see the pericardium, and let's look closer at how it encloses the heart. There's multiple layers. We'll start with the fibrous pericardium, the outer tough layer, and you can follow it superiorly to see that it actually dead ends right there on the great vessel. It actually reflects onto the roots of the great vessel and blends with their external layers. If you follow it inferiorly, you can see where it's attached to the diaphragm. So this is the diaphragmatic surface of the heart, attaching through that fibrous pericardium to the diaphragmatic parietal pleura. As we move in, we then meet the serous pericardium, and the serous pericardium is going to be divided into visceral and parietal layers, just like we divided up the pleura. Recall, the parietal layer would be external, and that's what you see here, fused with the fibrous pericardium. And internal, right on top of the heart, difficult to dissect off again, is the visceral serous pericardium. If you follow the visceral and parietal layers of serous pericardium superiorly, you'll see that they're continuous. And that continuity is represented by a reflection at the root of the great vessel. That continuity is similar to what we saw with the pleural sac And we use the balloon description to understand that. So that analogy also applies here. Now, this is a potential space that's created again. This is the pericardial cavity that is found between visceral and parietal layers again. And the green area seen here is a potential space that fluid is not typically going to collect, just a small amount to decrease surface tension and decrease friction. Here you see an anterior view of the heart with the pericardial sac removed. In your mind, place that pericardial sac back on the heart using that slightly filled up balloon and enclose the heart while the heart maintains its location outside of the balloon. So just as we talked about that with the lung, think how that can happen with continuity at the great vessels instead of the root of the lung. So you're going to have reflections where the visceral and parietal layers are continuous at these areas of all the vessels entering and exiting the heart. The one that actually can be a little more confusing is the base of the heart. It's actually immediately opposite of the apex that we saw coming here. When we follow back, we're immediately opposite here at the base. Notice the atria, the two chambers that receive blood for the heart, are really making up most of the base, specifically the left atrium here. And so as the visceral rolls off of its intimate connection to the heart itself and it hits some of these vessels, it's going to reflect off, and that's where we get our parietal layer. Now, these are the visceral and parietal layers of serous pericardium, and that's the two layers that are going to be surrounding the cavity. So when the heart begins development, it starts as a single tube and then it falls. And so you can see where the tube had the superior end here with our two main outflow vessels, the pulmonary trunk coming from the right ventricle and the aorta coming from the left ventricle. And then we have all of our inflow. So we have our inferior vena cava, superior vena cava, and pulmonary veins, everything that's bringing blood back to the heart. So let's put a line between those. We cover the heart as a tube and then it folds. And so we have a double layer here that comes together and creates a little fused area of those pericardial reflections. So above that, where we have our outflow superiorly and our inflow inferiorly, is a sinus that's created, a little recess from those reflections. That's the transverse pericardial sinus. Make sure this image here, with the surgeon's finger inserted in the space, helps you to understand that. Realize what they've done is removed the fibrous layer, cut open the parietal layer of serous pericardium, and entered into the pericardial cavity so fluid can move from the right to the left side of the pericardial sac. Now, we have one other recess that you'll see that's created here from that double layer pericardium. We create a blind cul-de-sac. All the reflections from the four pulmonary veins because they're entering the heart. But all of the reflections, as well as that double layer here, create a blind cul-de-sac within that pericardial cavity. And so you can appreciate how you could enter there but pass not all the way through as with the transverse recess. Here we see the right chest wall removed as well as the right lung and pleura. And that exposes the right root of the lung here. And remember, we were looking at how the phrenic nerve and the pericardiac cophrenic vessels run anterior to the root of the lung. In this lateral chest view, that is much easier to appreciate. We'll look at the vagus later and see that it tracks posterior to the root of the lung to run with the very posterior located esophagus. We're looking at an anterior view of the thoracic cavity here. You see the heart covered in pericardium and the faded out lung hiding behind some of the faded ribs and costal cartilages. Look at the axis of the heart here, a left oblique axis. Notice that more of the heart sits in the left chest than the right, and that the apex or the point here is located in the left chest. just there on the diaphragm. So the pericardium and the mediastinal surface here of the parietal pleura covering the lung are very intimate. And the nerve and vascular supply for both of those structures is sandwiched between those. Let's remove the lungs and connective tissue to better view this. So with the ribs out of the way and the lungs still faded, you can see here this vessel coming down the internal thoracic from the subclavian and giving off a smaller branch, the pericardiacophrenic. And where we have these structures sandwiched together, we also have the phrenic nerve. So this becomes a neurovascular bundle here. And this vessel is the pericardiacophrenic that's traveling between the parietal pleura and the pericardium with the phrenic nerve. That's your pericardiacophrenic artery and vein. Now, that phrenic nerve and those vessels are going to be sandwiched between those two layers. You'll have to dissect them off. But everything that they touch, they're going to have some sensory supply to, and we'll get to that later. Let's put this back in and go over some of the divisions and descriptive words now that we use to look at how these are situated in relation to all of these blood vessels we can see. We're looking at an anterior view of the thoracic cavity here. You see the heart covered in pericardium and the faded out lung hiding behind some of the faded ribs and costal cartilages. So the pericardium and the mediastinal surface here of the parietal pleura covering the lung are very intimate. And the nerve and vascular supply for both of those structures is sandwiched between those. Let's remove the lungs and connective tissue to better view this. So with the ribs out of the way and the lungs still faded, you can see here this vessel coming down the internal thoracic from the subclavian and giving off a smaller branch, the pericardiacophrenic. And where we have these structures sandwiched together, we also have the phrenic nerve. So this becomes a neurovascular bundle here. And this vessel is the pericardiacophrenic that's traveling between the parietal pleura and the pericardium with the phrenic nerve. That's your pericardiacophrenic artery and vein. So the course of the phrenic nerve, we know that it travels with the pericardiacophrenic vessels between the pericardium and the mediastinal parietal pleura. But where does it come from? It comes from C345 in the neck, and you're not going to see it yet, but it has a very distinct landmark in the neck, the anterior scalene muscle. We can look for that muscle and find it right before it dies between the subclavian vein and artery. Once it dives between the vein and artery, vein anterior, artery posterior, it will then descend to enter the thoracic cavity. Now, when it's in the neck, the phrenic nerve is lateral to the vagus nerve. However, as they move into the thoracic cavity, you'll see that the phrenic nerve becomes more anterior while the vagus nerve goes posterior. That means it's very important to put all these sections together because you can't memorize where a structure is in relation to another, because as they run through different cavities, that anatomical relationship changes. So here it is in the thoracic cavity and here it is in the neck. Make sure you understand its relationship to the root of the lung and the vagus nerve.
So let's quickly summarize what we have covered so far of these objectives. You understand there's a pericardial sac with multiple layers. You have the serous layers divided into visceral and parietal that are intimate with the heart and enclosing the pericardial cavity, and then the fibrous layer pericardium over that. The pericardium is very intimate with the mediastinal division of the parietal pleura. And in between those two, you'll find the pericardiacophrenic vessels and the phrenic nerve. Those vessels and that nerve will supply everything they touch. Sensory to the pericardium, oxygen to the pericardium outer layers, the mediastinal parietal pleura, the diaphragmatic parietal pleura, and even the diaphragm itself. We also looked at some recesses formed by the reflection of the pericardium in the areas of continuity. Make sure you understand those. And then revisit the origin of the vessels and the nerves that we've discussed. Make sure you understand some of the landmarks to locate those, like the anterior scalene muscle for the phrenic nerve and the root of the lung that separate the phrenic and vagus nerves. Thank you for your attention.